All right, Algebra 2, Lesson 31. We're going to talk about multiplying and dividing. Let's see, get over here. Multiplying and dividing rational expressions. So to multiply rational expressions, we want to multiply the numerator, multiply the numerators and multiply the denominators to simplify a rational expression, factor, and then divide out all of the common factors. To evaluate an algebraic expression for given values of the variables, we substitute the given values and then we simplify the numerical expression. One of the things that you want to remember is that a rational expression is undefined if its denominator equals 0. Okay. In this lesson, though, we're going to assume that all of our rational expressions are defined unless they're otherwise specified. Okay, so we'll always make the assumption that we're going to get a non-zero number in our denominator. Okay, so if we're dividing by a rational expression, then what we're talking about is dividing by a fraction. We can't divide by a fraction, but what can we do? Multiply by the reciprocal. So the reciprocal of a real number, say something like c over d is d over c, provided that c doesn't equal 0. Okay, because if c equals 0, whenever I flip it over to the reciprocal, now it's undefined, right? And d doesn't equal 0, okay, to begin with. So to divide by a rational expression, you multiply by the reciprocal. So a divided by b divided by c over d is going to end up being a over b times d over c, where b, c, and d are all non-zero numbers. Okay, so that's that. Let's get into, I should have had it pulled up, but I didn't. Okay, Algebra 2. We want lesson 31. Great. Okay. So let's hit. All right. So working out some problem types here. What we want to be able to do is first we want to simplify our expressions down. So I'm going to try to write on this. We'll see what kind of thing that we get. Does anybody see this x squared minus 9 that will simplify? X squared minus 9. Notice how we start with an x squared. Do we have an x value there? Just an x, like x to the first? No. But I do see subtraction, and what kind of number is 9? Perfect square. Right, it could be x minus 3 and x plus 3. Okay, this is frustrating. Okay, x plus 4 can't simplify. Then I've got x plus 2 can't simplify. But can I factor out anything from 4x minus 12? I can factor out a 4 and get x minus what, 3? Okay. All right, what about 5x plus 20? And get x plus what? Okay. All right, now x squared plus 5x plus 6 should be x plus and x plus what? What and what? 2 and 3? Okay. Nope. Nope, a little bit further. There we go. All right. So what we're looking for in here, and this is a giant mess, is we're looking for things that are in the numerator and the denominator. If they're in the numerator and they show up in the denominator somewhere, then I can eliminate them. Does that make sense? All right. Do I have an x minus 3 anywhere? Okay. Okay, and I also have it, I can't, there we go. I got an x minus 3 and an x minus 3. What about an x plus 3? Do I have one of those in both the numerator and denominator? Yeah? Okay. And then let's try that. I'm getting better at this. Okay. All right, what about x plus 4? Okay. There we go. All right, so that gets rid of that whole thing. What about an x plus 2? Okay. Okay, so what am I left with? 4. Left with 5/4. Okay, for the rest, huh? Yeah. Yeah, it was, yeah, for not being able to write where I'm writing, it was, yeah, it was a lot of fun. And it took way too long. So do we understand the process that we did first? All right, we reduced everything, all right, we factored everything, and then we looked for what could be eliminated. Okay? So I can't do that from there because I don't have it on my screen. So the rest of this, I think what I'm going to do, unfortunately, is I'm going to do this on the board, on the whiteboard, so that we can do this a little quicker. Unfortunately, what you won't be able to do is go back and watch it being done. Okay, so you're going to have to listen closely. I'm going to say this, I guess, maybe more so before I step on my Chromebook. It's going to be fine for you guys, but it's going to probably stink for the other Algebra 2 class. I'll probably just have to show them how to do these as well. Okay, so we have multiply and then evaluate for x equals 4. So we don't want to plug in x, or we don't want to plug in 4 for x just yet. We want to go ahead and evaluate it as much, or we want to go ahead and multiply it. So 16x squared minus 9. This is another one just like what we saw with the x squared minus 9, right? Because 16 is a perfect square and negative, or our 9 is a perfect square. So does anybody know what I get there whenever I factor it? What's the square root of 16? So I get 4x and 4x. Just anytime you see something like that where I've got a perfect square, x squared minus a perfect square. So minus and plus what? 3 and 3. Okay. Will the denominator for that reduce? No, it's just x plus 7. Okay. And then what about x squared plus 7x? Anything I can take out of that? Take out an x, and what's that going to leave me with? X plus 7. Okay, and then down below, this one can be a little trickier, right? Because it doesn't just give me a 4 on the beginning. So this one may take a little bit more guess and check. Like I could get 2x and 2x there, right? It's minus minus, which means it has to be a plus minus, right, in order to get a negative 6. All right, so that could be what, 2 and 3, right? Okay, positive 2, negative 3. But whenever I do that, let's see what it comes out. I would get positive 4x and negative 6x, so that's only going to give me, what, negative 2x, right? All right, so I should get negative 5x, so I got to deal with something a little bit bigger, right? I could do, we could try 6 and 1, right? So that's going to give me, what? That's going to give me negative 12x and positive 2x. That's negative 10x, right? That doesn't necessarily work, though, right? All right, so let's kind of go back to the drawing board and let's change, because there's only 2 ways to get that negative 6, right? 2 and 3 or 1 and 6. So now I have to go back. Maybe it's not 2 and 2 to get 4. Maybe it's 4 and 1, right? Maybe it's just 4 and x. Okay, so now I could try, we could try 2 and we could try 3. What's 4 times negative 2? Negative 8. Negative 8 plus 3, would that still give me negative 5? All right, so that looks like this is what I would get here, correct? Okay, so let's look through here. Do I have any 4x minus 3s in both? Yeah. 4x minus 3? Oh, I got 4x plus 3 in both. Okay, so we can eliminate both our 4x plus 3s. What about x plus 7? X plus 7 eliminates out in both, right? So what it looks like is, and you'll have to check the answer key to see, but looks like we would get x times 4x minus 3 all over x minus 2. What's the answer key say on this?
It's 4x squared minus 3x.
Okay. 4x squared minus 3x. So all they did, either one of these are equivalent to each other. The only thing that they did is they distributed the x back in. Sometimes they do, sometimes they don't. So either one of those two answers will work. 4x squared minus 3x over x minus 2, or x times 4x minus 3 all over x minus 2. Yes? What? Oh, okay, yeah, now we need to plug in our 4, but we're going to plug it into our final, okay? So we're going to do 4 times 4 squared minus 3 times 4 all over 4 minus 2. 4 minus 2 is 2, so I can get that in my denominator. 4 squared is 16, right? 16 times 4, I think, is 64. So you get 64 minus 12. 64 minus 12 is what, 52? 52 divided by 2, 26. 26 is your final answer. Does that match the answer key? Okay, cool. All right, so far so good? Okay, it looks complicated. Is it necessarily as complicated as it looks? I kind of hope not. It is. It's every bit as tough as it looks. This is going to be really frustrating, though, for people that are going back to like watch the video and nothing happens on screen. Okay. This one says divide and then evaluate. Okay, so can I divide by a fraction? Right, I can multiply by the reciprocal, so that's what I want to do first here, is get rid of the division and show it as multiplication. So I'm going to write negative 6x to the 7th over x cubed y squared times what? It's just the reciprocal. So we're not actually moving things across the division bar to do this, right? It's just the reciprocal. So we're actually not writing these as negative exponents. Okay, just the same way that if I was dividing by 5/3, I'm not going to write it as, 5 to the negative first over 3 to the negative first. You know what I'm talking about. Okay, so at this point, we can go ahead and multiply, right? Okay, so you could write that off as, negative 6x to the 10th, y to the 6th, okay, 3x to the 5th, y to the 2nd. Now what I can do is I can eliminate, right? I can simplify. What's negative 6 divided by 3? Negative 2. Now I can move those things up, right? So I'm going to get what? X to the 5th, y to the 4th. Okay, what's our answer? Is that it? Okay, now that I have this, right, I've got it simplified down to negative 2x to the 5th, y to the 4th. Now I can plug in numbers for x and y. Negative 2 times 2 to the 5th, y to the 1 to the what, 4th? Okay, well 1 to the 4th is going to be 1, which isn't ultimately going to end up changing anything, right? All right, so I'm really more concerned with 2 to the 5th. Is that 32? What is that? 32. Man, I'm good. 32. So we want negative 2 times 32. Make sure that you don't take negative 2 times 2 and then take that to the 5th first. Negative 64. Is that the answer? Great. Okay. Do a couple more of these. If you want, you guys can take a scroll through the rest of the questions and see if there's any that you want to cover before we close out, because you guys are out of here at 10:36. It's 10:21 right now. So I want to do you know, whatever would get us to maybe 1026, and then you guys can practice on your homework. Do you guys want to do 4, or do you want to skip down to something else? 8? Sure. Sure. Yeah, I actually like these anyway. All right, 8. X to the x plus 4 doesn't reduce, does it? Okay, but we can probably reduce x squared minus 9x plus 14. That should give me an x and an x. What are my signs in there for that? Close. Minus minus because it, right, I've got a, right, because I got a positive. So things that are going to multiply should be what, 7 and 2? 7 and 2 are going to add up to 9. 7 and 2 are going to multiply to be 14. So we got that. X squared minus 4 should see our pattern there. Yep. Okay. Anytime I don't see that, I see an x squared, but I don't see an x, I'm looking for minus a perfect square. If I have minus a perfect square, I'm going to get a sum difference, right? The same thing. I've got x minus 5 doesn't reduce. Okay. What can I factor out of the numerator in the next one? 2. That's going to leave me with what? X minus 5. Okay. Let's come down to the denominator. Okay, should get x and x, plus and plus. Probably what? 4 and 2? 4 and 2. All right. Now that we've got that, let's go ahead and look and see what occurs. I always start at the top left. Is there an x plus 4 anywhere else? Yes, I can get rid of my x plus 4s in the numerator and denominator. Let's do my x minus, do I have an x minus 7 anywhere else? What about an x minus 2? Yes, get rid of those. So do I have an x plus 2? Yes. Okay, do I have an x minus 5? Yes. Okay, this is the fun part to it, right? I like seeing everything cancel out. So I get 2 over what? Is that the answer? Okay, 2 over x minus 7. Okay. It looks complicated, but, I mean, granted, it's really funny if you're watching the video and you're like, it doesn't look like anything because there's nothing on the board, there's nothing on the screen. So, just so you know, it looks complicated. All right. I doubt anybody watches the videos anyway. All right, so that was 8. What else? Is there, we got probably one more question left in us. 6? Okay, good. Because you have several that kind of look like that between 4, 5, and 6. So let's take a look at 6. All right, it's just multiplication. So notice that I'm multiplying by something, but there's no denominator there. So what denominator is there? 1. So really, I can write this as x plus 5 over, we can simplify, we can factor out underneath that though, right? X squared minus 5x, what can I factor out? X, and that gives me x what? X minus 5, right? We're multiplying here. And I want to factor out, factor down to 6x squared minus 29x minus 5. That's kind of a tough one, right? Because we're going to get 1 there, okay? This is, like I say, it's kind of like a guess and check. So for that 6, we could get a 2x and a 3x, right? Okay? Now, the one nice thing about it is that 5 that we'd multiply to get is a prime number, so there's only 2 ways to get it, either 1 and 5 or 5 and 1, right? So, and there's really only one way to multiply to get a negative 5, and that's to have a positive and a negative, right? So, and we want our negative to be bigger, so we might have to change some of our signs around here. Let's make that a negative 5. Positive 1. So I have 2x minus 5 times 3x plus 1. Let's see if that works. 2 times 1, that's giving me a positive 2x. This is only giving me negative 15x though, right? I'm not dealing with numbers big enough to give me 29. So I need to change this to 6 and 1. All right, let's change that 3x for a 6. Let's change that 2 to a 1. So now I have 1x minus, or just x minus 5 times 6x plus 1. And that's a good indicator that I'm probably on the right track, because notice now I have an x minus 5 and an x minus 5, right? Those things will probably cancel out if this works. So x times 6x is 6x squared. Negative 5 times positive 6x is negative 30x. Plus 1x is going to give me negative 29x. So that all seems to work out, right? All right, so now we're looking at what things cancel. X plus 5 doesn't. Really only looks like x minus 5 cancels out. Okay, so that leaves me with just an x in the denominator, right? All right, and I would guess that they might want us to FOIL that. Does it look like they FOIL it in their answer? Or do they leave it like this? They leave it like this. Okay. So they leave it as 6x plus 5, or sorry, x plus 5 times 6x plus 1 all over x. Okay? We feel pretty good about some of that? All right. I will stop here. You guys can get to work. Everybody says that, and then they get started and like, I don't know how